Welcome to the Tools for Traders training session. Tonight will be backtesting, and this will be a single session. Take it, Ripper.
Thank you. Tonight's topic is the backtesting features built into the chart tool. Now, as opposed to some of the earlier lessons we've done, we're not going to be so heavy on the theory side today. We're going to spend most of our time actually playing with the backtesting features of the tool. And we're going to look at building a backtesting framework that will let you be able to run multiple backtests simultaneously. But let's get the show on the road here. So what exactly is backtesting? Well, we've got the definition here, or a definition. Backtesting is the general method for seeing how well a strategy or model would have done ex post. Backtesting assesses the viability of a trading strategy by discovering how it would have played out using historical data. So basically, the idea is you're going to take your trading system, you're going to pick some point in the past, and you're going to feed your trading system the market data from that period of time and examine the trades that it produces. And since, of course, this was all in the past, we can see how those trades would have worked out. So what this does is it gives us the ability to measure the performance of our trading system. And that's primarily the goal of backtesting. Now, backtesting, well, when people talk about backtesting, they tend to also talk about optimization in the same breath as if they're the same thing, when they are not actually the same thing. Basically here, optimization, you can see the definition. It is an act, process, or methodology of making something as fully perfect, functional, or effective as possible. Basically, you're trying to make something better. So for our purposes, optimization is the process used to improve our trading system. However, in order to optimize, you have to have some way to measure the current performance of whatever it is you're trying to optimize. If you have no way to measure the performance of it, you have no way to tell if what you're doing for your optimization is making the system better or not. So this is why a lot of people conflate optimization and backtesting and think they're the same thing when actually they're not. Backtesting is strictly giving us the ability to measure the performance of our trading system. And then optimization is the process whereby we use those measurements to improve the performance of our trading system. Now, backtesting and optimization is a major subject in and of themselves. And we can't, go too heavily into that in this lesson because we're going to be focused on actually using the chart tool and the backtesting features of the chart tool. If you want to get into a much more detailed discussion on backtesting and optimization in general, and this would be, the theory and all that behind it without any particular references to the tool, we have a presentation on our YouTube site. We have the link to it here. You could go and watch that, and that presentation will talk about the classic backtesting method as well as the method that was developed specifically for backtesting supply and demand based systems, trading systems. Now, most folks have a sort of intuitive understanding of what we're trying to get at with backtesting and optimization. They may not understand the details, but they have the gist of what we're trying to do. So we'll polish up that intuitive, feeling a little bit, and then we'll actually get into the details of the tool, and we'll actually spend most of the session playing with the tool. Now, on the previous slides, we talked about our trading system. And what we're going to do here is we're going to take that methodology, and instead of applying it to a trading system, we're going to apply it to what is a component of many trading systems. And that is the supply and demand bands that are found by the tool with whatever settings the user has given it to use. Now, the backtesting process, again, was targeted at a trading system. However, if we make a few simple assumptions, we can easily apply that to measure the performance of the supply and demand bands themselves. And we're going to be looking at measuring the performance here of the supply and demand bands as directly as we can. If you use the classic backtesting methodology for doing this, you would actually have to have them as part of an entire trading system, and you would test the entire trading system. And then as you began to play with the parameters for your supply and demand bands, you would again be attempting to see the difference that makes through the results of the entire trading system. Because of the way we're going to do things here, we're going to be able to look at the performance of the supply and demand bands directly without having to have all the trappings of a full-blown trading system around it. Now, the chart tool has a feature called the band test. And what the band test does is it allows you to directly look at the performance of the supply and demand bands generated by the tool over whatever specific period of time that the user specifies. And to do this, the band test is going to make some assumptions. We're only going to look at the bands that are created during the test period. Now, that's a statement about tracking. When we are doing the band test, we will be taking into account bands that were created before the band test started, because they will affect what bands are actually created during the band test. If there's a prior existing band from before the test started, and we're looking at a pattern during the band test, and that pattern is a retest of the band from the historical band, let's call it, the one from before the band test started. Well, if it's a retest, a new band is not going to be created there. But if you don't take into account prior bands like that, then you can get somebody please mute their mic. But if we were not to take into account prior bands like that, then we would potentially have a new band being generated, and that would not normally be the case. So We're going to be looking at bands that are created during the test period. The bands that are created during the test period, will be affected by bands from prior to the test period. So when we're running the test, we want to make sure we have enough data loaded for the tool to find bands that are prior to the test that could affect the test. And these bands that are found, which are prior to the test period, we're not going to be tracking those with the same kind of detail that we track bands that are formed during the test period. We're going to be tracking a lot of extra data for the bands that are formed during the test period. Now, we're going to also assume that we're going to take a trade on every band, every supplier demand band that is found during the test period. We will assume that we're going to get into the trade the very first time that price returns to the band. We're going to assume that all trades consist of a single unit that's appropriate for the market being tested. So if you're testing futures, it would be one contract. If you're testing stocks, it would be one share. We're going to assume that you're going to get out on the biggest bounce off of the zone, off of the band, the supplier demand band. If you're trading the supply and demand methodology, we use the supply and demand bands to predict where price is going to change direction. And then we are trying to play that change in direction. And it's often referred to as the bounces off the zone when price comes into the zone and changes direction. But we try to make our money off of those bounces. So the tool is going to be tracking the max bounce. We're going to assume that you're the perfect trader and you can actually capture that maximum bounce. So we're going to assume we get into the trade when price breaks the proximal line, and our stop is going to be one tick past the distal line of the band. This makes our risk the width of the band. Now, given all of this, we can define some values which will be useful to us. Again, I already mentioned the maximum bounce, but to give a bit more formal definition, that's going to be after price comes in and hits the proximal line of the zone, this is going to be the furthest distance away from that proximal line that price gets after it's bounced off of the zone. So I guess you could say that would be your maximum possible profit from that zone. We can also go in and define a reward to risk ratio. And that would be then the maximum bounce divided by the width of the zone. And we're going to say a successful band is one which produces a reward to risk ratio of at least 1 or more. So given this, we can come up with some metrics to measure the performance of our supply and demand bands. The first metric we'll talk about is the success rate, which is going to be the percentage of the bands found during the test period which produce reward to risk ratios greater than or equal to 1. And the next one is something that's unique to what we're doing. We call this the points available for capture or the points in play. But what we're doing is we are going to look at the maximum number of points that can be made from the bands found during the test period. And basically the way we're going to do this is we're going to take all the maximum bounces for all the successful bands, and we're going to add that together. And then for all of the unsuccessful bands, we're going to subtract the width of all those bands from the total. And that will leave us with how many points are available to our trading system to attempt to capture. So if we played every band and we did it perfectly, that would be the amount we could theoretically make. And this is a bit different from, traditional backtesting methods, because traditional backtesting methods, you have no way to come up with that value. Traditional backtesting methods are black box methods. They don't really know anything about the particular trading system being used. And so as a result, they have no way to predict what the maximum potential of the system is. But here, since we're using white box testing, which means that we're taking into account some things we know about the system being tested. In this case, it's the supply and demand trading style. Because of that, we can go in and actually calculate approximately what the maximum theoretical value is for what we could make. And this value is useful because we can then use that to determine the efficiency of our trading system. And it gives us something to measure the performance of our trading system against. So those are the two metrics that we're primarily going to be looking at. Now, let's talk about the basic process involved in backtesting and optimization. I've already mentioned that we're going to be using historical data. We're going to pick a period in the past. We're going to take what the market did. We're going to feed that into the system, and we're going to see how the system performed. Now, how do we choose that historical period? Well, one obvious way to do that is to choose a historical period where the market was behaving very much like it is today. And that way we can get an idea of what to expect from our system under current market conditions. But if we suspect that the market conditions are going to change for whatever reason, then we may choose a historical period which we believe is going to be like what we're going to see in the near future. So essentially at that point, we are testing our system against what we expect market conditions to become. Another thing, maybe we just want to test our system against a specific unique set of market conditions. If there was a particularly interesting period where the market was behaving in an unusual fashion, we may wish to see exactly how our system would handle that. And then another method that is sometimes used is to just randomly sample, periods of time that, basically just historical market activity is really what we're doing here. We're just randomly sampling that by picking out periods of time in the past to get a more general idea of how our system will behave over time. So those are some of the ways that people will pick what periods of time from the past to test their system against. For instance, if we're expecting another major market downturn, we may go and look at the last time there was a major market downturn and see how our system performed during those conditions. So that's the kind of thing that we're looking for when we're trying to pick test periods to use for backtesting. Now, once we've decided on the periods that we're going to test against, we're then going to run the band test using the default settings for the chart tool to establish a baseline for comparison. And we're going to do this for each of the historical test periods that were selected. So there we can see how the tool is performing with its default settings. And once we have our baseline for comparison, we can then look at the settings that we're interested in perhaps altering. And we're only going to work with one setting at a time, but we're going to go in, make a change, and then we're going to rerun the band test. And then we can examine how the performance of the system changed based on the change we made to the setting being tested. And this has to be done very methodically so that you can minimize the time you actually spend back testing and still have a very high probability of getting results that are near the optimal. I'll put it to you that way. So let's get a quick look here at some of the data we actually get from a band test. Now, what we have here is a short test. It was 1 month on a 60-minute chart. So in terms of, being statistically valid, it's probably not, because the sample size is too small. But this will give us an idea of the kind of things that we can get out of the band test. This has also been edited so we can get it all into one slide here. There's actually a lot more information that you're going to get out of a band test than what's here. But this has the things that we're going to be concentrating on. So the first item here, is the success rate. And right now it's showing at 48%. And again, this is the raw success rate without odds enhancers or anything else. Normally, when you're doing the supply and demand trading method, after you've got your zones, you're going to apply odds enhancers to pick, which of those zones you're actually going to use for a trade. And those odds enhancers are essentially filters. They're going to take some of the initial zones you found, and they're essentially going to throw them away. So you're going through a filtering process. Well, what we're looking at here is the unfiltered raw data. So the better we can make the initial unfiltered raw data, the better the filtered results should be. But keep that in mind. So right now, before filtering, we'd be starting at 48% of the zones found give us 1-to-1 or better bounces. So we don't actually have to go that far to get above 50%. And with just 1-to-1 trades, if you're over 50% with your success rate, it starts becoming possible to make money. Now, of course, we want to get that success rate as high as possible, but this is a starting point, a stake in the ground, if you will. So what we can see here is the success rate. And of course, we can see here the test period, and we can see the symbol and the interval, that kind of stuff. Again, there's a lot more that's actually put out, and we clipped that off here to concentrate on the major items. Now, what's happened here is we're going to get two tables from the tool. The first table is going to list all of the supplier demand bands that were created during the test period and which were broken before the end of the test period. The second table is going to list all of the supplier demand bands that were created during the test period, which have not yet been broken, which means we may not yet have seen what their maximum bounce is. So you could consider those runners, if you will. Now the table here, this is sometimes called a bucket list, but it's organized by the reward to risk ratio. And a reward to risk ratio of 0, we consider to be a stop out. This means basically in the first table that the zone was broken and we did not get a bounce off the zone that could make it to 1-to-1. So all of these we consider to be stop outs. And we can see how many of those there were, and we can see how many points we would have lost trying to play those. That's what we have in the different columns here. Now the next row is all the ones that made it to 1-to-1, but not to 2-to-1. And again, we can see how many points we would have made with those. The next row is showing us all those that made it to 2-to-1, but not 3-to-1. And so the last row there, the 13, again, this is ones that made it to 13-to-1, but not 14-to-1. So we can get an idea of the distribution of the winners and the losers. The next table, of course, is our runners. So the numbers here could still improve. And again, we can see the distribution of all of those. And if we were to take all of these points, this last column, we could add that up, subtract out our losers up here in the 0 column, or the 0 row, I should say, of the table. And that will give us our points available for capture, the points in play. So if we were able to play all of these zones perfectly, we could make 18 and change points per contract. So that's what's on the table, and that's what we're trying to capture with our trading system. So when we actually start going to backtest and optimize, focusing again on our supply and demand bands, as we go and make changes to the settings, We can go and look at the success rate, and we can look at the points available for capture, as well as the tables here showing us the distribution of the winners and the losers, and see what exactly our change did. Did our change improve the overall distribution of winners and losers? Did it go and change the overall success rate? Did it give us more points available, to be captured? What did it do? And we can measure that and then work towards making that more acceptable for our trading system and for the psychology of the trader, because that's another factor that goes in here. Often you'll find that you can optimize the system for performance, or you can optimize the system for safety. So if you optimize for performance, you're looking at the points available for capture primarily, and you may end up with a lower success rate, but a higher points available for capture. And there's more risk in such a system, but there's also potentially greater rewards. Having a lower success rate can be quite challenging mentally for the trader. You could optimize for the success rate instead. That may actually lower the points available for capture, but the higher success rate is often a lot easier to deal with mentally for the trader. And then it becomes a question of, can you make enough money to accomplish your goals? So let's go in and look at the actual settings involved now. There's not a lot. These are the actual band test settings. The first setting, true or false setting, and it's just going to enable or disable the band test feature. By default, it's disabled. The band test does take up a lot more memory and CPU, so be aware of that, because there's a lot of extra work that's being done there and a lot of extra information that has to be stored. And we talked before how we need a historical period to test. And the next two settings, the band test start and the band test end, define that historical period. Now you have to make sure on your charts that you have enough data loaded. And you want to have a sufficient amount of data before your test starts so that the tool can potentially detect any supplier demand bands, which could have an effect on those made during the test period. And you're also going to want to have some data after the end. You don't want to have your data end before the end of the test period or right at the end of the test period, because the tool is going to need to see candles after the end of the test period in order to determine that the test period has ended and to start flushing out its buffers and complete some of the work it's doing. So you always want to have some data after the end of the test period. Now, how much data you need before the test period depends on what the market was doing before the test period. If the market was moving sideways in a fairly tight range, you may not need a lot of data before your test period, because you just need enough data to cover the range and any supplier demand bands that would be created by that range. Whereas, if the market was in a consistent uptrend before or a consistent downtrend before, you may want to consider having some additional data so that if the market changes course during your test period, you found enough of the supplier demand bands from before your test period that could have an effect on the test. And again, the primary interaction here becomes are patterns found during the test period, a retest of a supplier demand band from before the test period or not. If they're a retest, then they won't generate a supplier demand band. But if they're not a retest, they will. And so the tool does need to know about supplier demand bands from before the test period that could act as the source of a retest, and thereby affect the generation of new supplier demand bands during the test period. Now, by default, the band test is going to generate a summary of the results, and the summary is what we saw in the prior slide. Now, to control where that summary is placed, you have the band test base file name. And this is a path name from the file system that basically tells the tool where to put the summary file. And it also gives the first part of the name of the summary file, and then the tool will append a series of things to that base name. Now, the tool captures a lot of data during the test. Every time price comes back to a supplier demand band, there's a whole range of things that are captured and date and time stamped and everything else. And one of the things that's captured is the RSI value at that point in time. And so we need to know what period to use for the RSI. The default is going to be to use, 14, I believe that's the standard for the RSI. But you may want to change that to match whatever you're using, in your trading plan, if you decide to use something other than that. You'll find that a lot of people who trade lower time frames will also lower the period for the RSI to speed up and make it more responsive to what's happening on those lower, faster moving intervals. Now, the last setting here, disable graphics for band test. This will basically turn off the output from the chart tool. And the reason you may want to do that is because on large tests, like let's say you're going to test 6 months on a 5-minute interval, that's a lot of data that's going to be downloaded by TradeStation. That's a lot of data that's got to be processed, by the chart tool. And if you have the chart tool operating normally, and he's putting out all his graphics commands to TradeStation, that's a lot of calculation that TradeStation is going to do to put all those bands on the chart and everything else that the chart tool puts on the chart. And we have found that by disabling the graphics, we can cut the runtime in half or even more on larger back tests. So that gives you an idea of how much time TradeStation spends on the graphics, making your charts look really good. This is probably why their charts look so much better than everybody else's, but like everything, there's always a price to pay somewheres. So these are the settings for the band test itself. Now, getting the summary report out is all well and good, but we would often like to have the actual raw data that backs up that summary report. And that way, you don't have to trust the tool. You can actually have the raw data. You can look at it yourself, or you can go and do further analysis. And that's why we have the band event logging. Now, you can have the logging turned on even if you're not doing a band test. And there's a bunch of useful information that will be logged about every supplier demand band that's created. You can find out when it's created, when it's removed from the chart because it's been broken, and find out when price comes back and penetrates the band every time price comes back. But when you have a band test running, there's a lot of additional information you get as well. And having that additional information can be quite useful because you can load it up into a spreadsheet and potentially do further analysis on it. So the first setting here, this is our switch for turning on the band event log. It's true or false. True turns it on, false turns it off. The default is false. There is a bit of a performance hit, of course, involved in having the logging on because now you have the system doing something extra. You can set a path name for the log, which tells it where on your disk drive to put the log and what to use as the basis for the name of the log. And then the tool will append several things to whatever you give the name or whatever you give it to use as the base of the name. And this next one here, band event log is CSV. This allows you to specify the format of the log. The log can either be in a human readable format, in which case you would specify band event log is CSV is as false, or you can have the log turned out as a CSV file. CSV stands for comma separated value. And CSV files can normally be imported by most spreadsheets. Excel, for instance, will pull in these log files very easily. And so that's how you can get the information from the band test in a format that you can easily import it into external tools, such as Excel. Now, the next setting, the log candles, tells the tool whether or not you want information on every candle it sees included in the log file. And again, that's something that's really targeted at using this log file with external tools. And so this gives you a way to get the candle information that the tool saw in the order in which the tool saw it into that log file for import into some external tool. Again, the default on this is false because that can lead to some really big log files. And for a lot of the stuff, you may not need that. It really depends on what you're trying to do as to whether or not you need that. And then the last setting here tells the logging system to only log band test events that apply to bands during the test period of a band test. So basically, it restricts the data to just what happens during the band test. All right, let's go and actually start playing with the tool. Let's see, end slideshow. There we go. Let's get this out of the way here. All right, I'm gonna come up here and make a new workspace for us to play with. Let's bring up a new chart analysis window. Let's see what TradeStation gives us today. All right. Let me clean this up a little bit so it'll show up a bit better over Zoom. Okay, the fonts are already adjusted. Make the background a little bit darker. Get rid of the grid. Okay, so today it gave us MNQ instead of ES. All right, interesting. We happen to be on a tick chart here, but it really doesn't matter whether it's a tick chart or a time-based chart or a share bar chart. The tool receives the data from TradeStation in the same way for any of them. It's all just a stream of candle data in essence. So the tool really doesn't care what kind of a chart it is. It's up to the user to make sure that whatever chart they're putting it on, it makes sense to do so. So let's go and add the chart tool now. Go to add study. All right, chart tool beta 2. All right, here we are. We're just going to start with the defaults. Okay, so he came up pretty much with the defaults. Now here, I'm going to go to my chart tools data directory. If you install the tools, we had you create this directory on drive C. This is going to be the default location for a lot of things we're going to do. As you can see, I've done a lot of things here. Let's get rid of this. We'll recreate this. Okay, so I'm going to create a test directory here. And we're going to put our band test results into the test directory. So I'll create a new folder here. We'll just call it test. So in here is where we're going to start placing our results. Now, what would be an interesting period of time to look at? We can go back and look at before COVID, I guess. Or shall we look at during COVID? Let's start out easy. We'll go back and look at last year, right? We may want to go to a time-based chart here. We'll go to a 15-minute chart. Okay, so let's go into the tool. And we'll go look at our settings for the band test. So at this point, we're just getting our baseline. So we're just going to leave everything at default here. The settings for the band test are pretty far down. Here we go, band test settings. So I'm going to set this to true. Put a pound sign after it, preserve the existing setting. And now let's look at our time period that we actually want to use as our historical time period. So let's go back, I don't know, let's say, January of 2022. You know, we'll do January and February. What the heck, right? We'll look at those 2 months. So the format for entering the date and time here is actually listed as part of a comment for the band test start and the band test end. So that way you don't necessarily have to refer to the manual for that. All right, so we'll do 01. 2022 is the date. And for the time to start this, we'll do 00:01, 1 minute after midnight. So that's when we'll start our band test. We'll end it, let's say, March 1st. Well, so that'd be 03, 01. So I'm going to have it end 1 minute before midnight on March 1st. And I'll put my pound sign there. Now for the file name here, we need to put in here, let's see, this is all caps, backslash, chart, data, slash, test, slash, band test. So what I've told him is to put it in this. Let's see if Windows will show us. There we go. C:\chart tools data /test, because it's the test directory we created. And then after that, I gave it another / and I gave it the base for the file name. And I called that band_test. So the tool will name the file band_test, and it's going to append some other information about the market and interval and whatnot, the date, time stamp, all to that base that we gave it to start the file name to create the final file name that will be used. And we'll see this. It becomes a lot clearer when you actually see it in the directory. So this is where we want the files to come out. So we'll come back and look at that after we've done this. Now we'll leave the RSI at the default. And there's a pretty small test, so we don't have to disable the graphics for this. It won't make that much difference because it's a relatively small test. Now we'll do it this first time without the logging. And by default, odds are good we don't have enough data loaded to cover that time period, so we may not get anything at all. And then we'll go back and we'll adjust. In fact, we should probably turn this off until we've actually got the data loaded for it. We'll do that. That'll save us some time. All right, so we said we're going back to 2022, right? So let's go in here to edit symbol. And let's go with first date. Let's see, we'll start this, what, a month, let's say, before the test period here. Can I enter that directly? No. All right, so I'll start this December 1st of 2021. And then up here, let's go and end this, do it this way. There we go. Let's see, our test's going to end on March 1st of 2022. So let's just say we'll go with the 15th. So we're going to have them load data starting at December 1st of 2021, which is about a month before our test period is going to start. And he's going to load the data through the middle of March, which is a couple of weeks after our test is going to end. So this way, he's got some data before the test to try to find zones that may cause changes in the zones that are found during the test period. And he's got a couple of weeks after the test ends to flush out his caches and everything else he does. So let's go back now. We can turn on our test as soon as the data gets loaded. Hopefully that's not going to take too long. Now we'll see how many supply and demand bands we get. The more, the better. But generally speaking, to be statistically significant, it has to be, what, more than 30 or 31, I think is the magic number, something like that. But generally speaking, the more the better. Come on, TradeStation. Since the markets are closed, they've probably taken some of the servers offline for maintenance. We'll have to see how long. Okay, we're starting to get data. We don't have all the data yet. At this point, he's trying to overlap the loading of the data with the calculation of the indicators. So we have to wait and see what we can get here. Now, on a lot of the back tests, you'll end up spending quite a bit of time waiting to get all the data you need. Now, one of the things we'll look at in a bit is combining the backtesting features with certain other features we've talked about in prior lessons that will let us go and run multiple backtests simultaneously. TradeStation is capable of using multiple cores. So if you have a system with multiple cores, we have the possibility of overlapping the running of band tests. And we'll talk about how to do that in a little bit. But first, let's get the basics. So now we've got our data. First, we'll check our directory. You can see that's still empty. So now we'll go in and we'll turn on the band test that we previously defined. I'm just going to scroll down here until I start seeing band event log. Okay, and then here's the band test. So I'm going to set this to true to turn on the band test, setting 370 here. We can still have everything set up. We have our path. We're set to put the results in chart tools data under the test directory. And the file name should start with band_test. So let's see what we get. Now this will take a little bit longer than normal. Because of all the extra items that are being tracked and the extra work that has to be done to create the summary report. While he's doing that, let's come and look over here. We can see now we have a file in our output directory. We can see it began with the name band_test like we specified. The tool has added the symbol to the name. It's also added the interval to the name. And it's even added a date and timestamp to the name. Now the size here is going to be listed as 0 until the report has been completed and the file is closed by the chart tool. And then all of a sudden you'll see the size of the file change. Okay, it just changed. It's showing 9 kilobytes now. We can see here the type of the file is a band test file. And this is the text file. So we're going to open this. The first time you do it, you may have to tell it to use Notepad. But this is what was generated. Now, this is the part that you didn't see on the slide. And what's listed here is the value of all the settings that affect the band test and the bands that could be discovered. You know, up here, it starts off with a date timestamp of when this was actually run. So this is the current date and time. So you can see here it's in TradeStation format. So the year is 1st, 2024. Then comes the month, 01. And then comes the day. You can see here the time-wise, this is military format. So that's 21 hours, 24 minutes, 18 seconds. We've got the symbol. We've got the interval for the chart. We have the point value for the market we're looking at. The min move and the price scale. This is some internal TradeStation ID stuff. We're looking at a futures contract. So this is the expiration date for the futures contract. We have the test period. And we can see here it's what we specified. January 1st of 2022 through March 1st of 2022. And then we get into all the settings in the tool that can affect how supplier demand bands are found. So all of this is here in case we have to reproduce this result in the future. And then down here, we actually get into the summary of the results. It's a little wider. There we go. And now this looks like the slide we saw in the presentation. only with more detail here. So we have, again, our test period up here. We can see how many candles the tool got to see during that test period. We can see how many actual supplier demand bands were found, how many of those price actually returned to. We can see some special cases which did not get hit, so that was a good thing. We can see how many were broken by the end of the test period. And we can see how many runners we still have. And overall, during this time period, 41%, a little over 41% of the supply and demand bands found produced a 1-to-1 or greater bounce with the settings that were used here. Now we have our first table here, which shows us the results for all the bands that were broken by the end of the test period. The second table is our runners. But we can see he did find some larger winners here. There's a 38-to-1 and a 39-to-1, 29-to-1. We can see here all of the stop outs. And we find that most of our stop outs were drop-based drops, which is interesting. So this is all the points that you would have lost if you played every one of them. And then we start getting into our others. Here's our 1-to-1s that didn't make 2-to-1. Here's our 2-to-1s that couldn't make 3-to-1, and so forth and so on. And we can see how many points we could have made if we had played all of those perfectly. We can come down here and look at our runners. Wow, we got 134-to-1 that's still running. Oh, that was unexpected. But we can see we have some major runners there. And if we go and we add up all of the points and we subtract out our losers up here, the number of points that the market put on the table for us is 19,847. 19,847. So if we had played every zone and played everyone perfectly, we could have made over 19,000 points per contract. And since this was the micro, that's what, $2 a contract, or excuse me, $2 a point. So you're talking over $38,000, almost $40,000, per contract was possible. So that was the theoretical max. So this is a very simple, very basic case. Now, this time let's go in, we'll make a change. This was done with the default, which is band creation method 3. This time we'll run it again, but we'll use band creation method 5 to see what kind of a difference it makes. And we'll also turn on logging this time, so we can see the raw data as well as the summary. So minimize that. Let's go back in here. So this time we're going to do band creation method 5. Here's band creation method. This is setting number 11. So I'll put a 5 in there, and we'll put the pound sign to make everything after it a comment. And let's go down. Start looking for, up there we go, band event log. All right. So I'm going to turn on the band event log. And let's tell it where to put our band event log. Let's see. Actually, this might be easier to just come in here and try to copy this. That we can grab that. That's close enough for government work. Let's come back up here. Instead of calling this band test, we're going to call this band event log. Okay, we have a pound sign so that everything that was there before will be a comment. Okay, so it's going to go to the chart tools data directory, then underneath the test subdirectory. And then this is going to be called band event log. And then the tool will add the market and all the other stuff that we saw added to the file name for the one we just ran. But now this is going to be the log. I do not want a CSV for this first one. We'll actually get him to put it out in a human readable format first. We don't want the candles. We don't need that. That's going to make the log really big. And I only want the data from our test period. So let's see what we get this time. Hopefully there's no typos. Okay, we've already got 2 files created here. So this will take it a few moments, but this time we'll have our summary report, and we're going to have all of the raw data backing up the summary report. And this time the raw data is going to be in human readable format. In the future, we'll flip the switch and we'll have that coming out as a comma separated value file that you'll be able to load into Excel. And then you'll be able to do, again, further analysis. We do have a sample spreadsheet available on the website that shows how you can do additional analysis work. So you can see it does take a little time to do. A lot of that depends on the size of the test period and how much data you have loaded before the test period and after the test period. Okay, so this should be our new one here, our new summary. And here is the data that backs up the summary. So let's go in and look at this. Come on, Windows. I want to look at this with Notepad. Again, it's just a text file. You can see this time it tells you it is the band event log that we have loaded. And why did you do that, Windows? We suddenly moved that to another monitor. How nice. Okay, so we can see here again, he puts out all of the settings that are required to reproduce the test. So this gives you a record of what was actually used for your test results. And as we scroll down some, you can see what an event looks like in the log. The event is going to start with the right angle brackets and it'll end with left angle brackets. And he's going to put out a whole series of data, about what happened at that point in that particular event. So here's a band penetration event where we have price coming back to a supply band or a demand band. It's going to be date and time stamped. You'll have the candle number. You can see that this band was a demand band that was being returned to. It was an active band at this point in time. It hadn't been broken yet. You've got the origin, date, and time stamp for the band. You've got the candle number for the leg in, the candle number for the leg out. You've got the proximal line values, the distal line value. You have the information on the candle that actually penetrated the band. You have the pattern that created the band. Let's see what else we got here. The date timestamp of the first time that price tested the band. You have the position on the curve. This is expressed as a percentage, where the bottom of the curve is 0%, the top of the curve is 100%. So this particular band happened to be in the middle of the curve at the time that this particular penetration event occurred. You can see so far the maximum bounce we've had off the band was 15 3/4 points. And you have the date and time that occurred. This was the second band that we found after the start of the test period. And at the time price penetrated the band, you've got the bid, the ask, the RSI value, the ATR. You have information on the first opposing band and also on the first fresh opposing band. So this gives you an idea of the things that the tool is capturing when you're doing a band test. And you can see as we go through here, you can see there's a band deletion event down here. So a band was broken and band was removed. It happens to be band number 1. It was the first band found during the test period. And here's a band creation event. It tells you it was a rally-based rally that led to that being created. But again, there's just a ton of data in here. And again, this is all the data that backs up the summary. Now let's go look at the summary. So here we have the summary. And you see here it's labeled chart tool band test, whereas the other one said it was the event log. And again, it's going to start out giving you everything you need to reproduce this test, should you ever need to do so. So all the settings and their values that could potentially affect the test are all recorded here. And then we get to the summary at the end. Let's see, we changed what? We changed the band creation method. Let's go look at that. Oh, this is the old summary. Let's pull up the new one. Yep, here it is. This one's got the later date. And yep, band creation method 5. Okay, so let's go look at the summary of the old one. We'll look at the summary of the new one, and we'll see if the change we made a difference. Okay, so we can see the test period is the same as the first 2 months of 2022. We can see the number of candles was the same, but we can immediately see that the number of bands found was different. What's the difference between band creation method 5 and band creation method 3? Band creation method 5 draws wider zones. So you could have some situations with the narrower zones of band creation method 3 where you had what's commonly called a level on level. But when you draw your zones wider, all of a sudden that level on level goes away because the second level becomes a retest of the first. So you'll tend to find you get fewer zones with band creation method 5. And that's what we see here today. The difference isn't huge. I mean, we went from 214 down to 192, but this is over a 2-month period on a 15-minute chart. No special cases. We see that 179 of the zones found were broken. So we have 13 runners drawing our bands wider. Whereas when we draw our bands narrower, there were only 7 runners. The success rate, the percentage of bands that gave us 1-to-1 or greater bounces, is actually better when we draw our bands wider. So while the narrower bands are attractive because they limit risk, they actually have a lower success rate. So are they really limiting our risk? That's something to think about. Again, we have our bucket list showing how many of our zones produced different kinds of bounces. So our stop outs with the narrower zones, we had 116. With the wider zones, we had only 107. However, when you look at the points that would have been lost to the stop outs, even though we had fewer stop outs with the wider zones, we did overall lose more points. But when we start looking at some of the others, like the 1-to-1s, the wider zones, we made more points on 1-to-1s than we did with the narrower zones. And that's typically a scene we see throughout. I mean, you can look at all of these and compare them. But the bottom line is, when we look down here at the points in play, which is the total points available for our trading system to attempt to capture. We can see that there was a lot more points available with the wider zones than there were with the narrower zones. So even though our risk was a bit higher per trade, there was a lot more to potentially be gained. And we had a higher success rate as well. So here's a possible optimization to be made for, let's see, we're on MNQ on a 15-minute chart. Now, overall, the tool does know 6 different ways to draw a band from the pattern found. And you could go and run each of those to find which one works best for the particular market you're trading. And sometimes there are significant differences between them. I mean, here we saw there was a big difference between them in terms of the number of points that the market was putting on the table for us to try to capture with our trading system. But the difference wasn't as big in terms of the success rate. But this is, again, a simple band test. Now, we can start to combine the band test with some of the features from the tool we saw in our earlier lessons. So one of the things that we can do, especially if we want to try to run multiple band tests simultaneously, is we can use the feature of the tool that allows you to share settings between windows. So what we're going to do next is we're going to create several chart windows. We're going to have one chart window that's set up to control the others. And we're going to have each of the other chart windows set up to test a specific band creation method. So what's going to happen is the window that's controlling all of the others is going to send his settings to all of the others. The others are going to accept those settings, and then they're going to override one setting, that being the band creation method. And so this way, we have our one window which is controlling things, and we can potentially vary other settings in that window. And as we vary other settings, those changes are propagated to the other windows. And we can see how the band creation method is affected by what we change in the first window. So let's look at setting that up. And again, it's not hard to do. It just takes a little bit of planning. So we have our directory here where we're collecting our data. And underneath here, I'm going to create a series of directories. One is going to be for the sender. And then I'm going to have one for each of the chart windows that is going to be receiving those settings and doing a different band creation method test. So I'm going to call this first one sender. Next one, I'm going to call receiver 1. So we can have sender do one of the tests. Receiver one does another. There's 6 total. So we'll want 6 directories here, and that'll easily let us keep the results from our tests separate from each other. Another way we could do this would be to have each of the receivers using a different name for the files they produce. Putting them all in one directory, though, can get confusing. So based on experience, having the separate directories for each of the windows participating in this tends to keep things cleaner. So let's create, let's see if we need another 4 here. Okay, so we have our 6 subdirectories. Now let's go in and create our chart windows to go with that. We'll make this window into our sender. And the first thing I got to do here is I have to turn off the band test. I'm going to turn off the band test. I'm going to turn off the logging because we don't want him, generating stuff while we're trying to set all this up. So let's see. So I'll just put this back to the default. And here's the band tests. Now, it's important to note that the log settings and the band test settings are under the control of the OSF system. And it's the OSF subsystem that allows us to actually send the files, send the settings in an OSF file through the TradeStation Global Dictionary from one window to another. Okay, so to make this guy the sender, here, whoops, did I go too far? Yes, right here. Here we go, send settings. So I'm going to set this to true. And we'll use the default name CT1 because there's not going to be any other senders here. Okay, so that was quick. Or is he still thinking about it? Come on, TradeStation. Nope, TradeStation was thinking about it. Come on, TradeStation. Okay, finally. All right, so let's shrink this window down a bit. I want cooperate trade station. Okay, let's get this back the way it's supposed to be. Here we go. All right, so we'll make the sender our leftmost window here. I'll have to shrink these down to make enough room. All right, so let's copy this window and we'll paste it. I'll have to remember not to do heavy data use things on TradeStation on Friday nights. Come on. Now, once we get the window up, one of the things we're going to do is we're going to use the symbol link and the interval link. And that will link our two windows, our sender and what's going to be our first receiver. And that way, if we change the symbol or the interval in the sender, that will get propagated to all the other windows as well. So that way we could just save this workspace, and whenever we want to change or check the different band creation methods and their performance, we can just open up the workspace and go to whatever market and interval we're interested in. Everything will be set up and ready to roll. All right, let's get this guy up over here. So we'll set the symbol link here. Come on, TradeStation. There we go. Now I'm going to set this to the green global link. And that way we can have additional workspaces and add them into the framework as well. Have those performing additional tests, not just the ones we're setting up here. And I'm going to set the global link again here for the interval. And we'll set the green global link. And we'll set the green global interval link. So let's go into the settings for this guy here. And we're going to turn him into a receiver. So we're going to want him to be set to default for everything. except for the band creation method we want him to test. So we'll have the sender, we'll make him band creation method 1. This first receiver will make band creation method 2. So this guy will get his settings from the sender, who will be sending band creation method 1, and then he'll override the band creation method and set it to 2 while accepting all of the other settings from the sender. And so let's go down. So here we're going to set our logging. Let's get to logging here. Okay, so the logging is going to be set to the default. We just have to change the location here so that his logs will end up in a different location than the sender. And this guy was going to be receiver 1. Let's check our directory. And it is receiver space 1. Okay. So I have inserted receiver 1 into the path name here. And that should do the trick there. I'm just going to set everything else to default, so we'll just get whatever the sender sends us. And it's going to be the same thing here. We're going to want everything at default because the sender is the one who's going to tell us what band test to run. On the interval link, should go and load the correct data. So we shouldn't have to worry about that. But the file name, this we have to override because we need this to go to the right location. And so I'm again going to insert receiver 1 here. Okay. So now this guy's pointing to all the right places. And so now this guy is not a sender, so we'll make sure that's turned off. However, he is going to be a receiver. And we're going to let him receive everything that the sender sends. Okay. All right. I think we've changed everything we need to change here. So let's save that. Hopefully there were no typos. Now we have to wait for TradeStation. Setting this stuff up is actually a lot harder than actually running things once you have it all set up. But once you have it set up, you can save it. And then the next time around, you just load it. Okay, he's still busy calculating. Definitely don't want to do this on a Friday or a Saturday. Okay, there we go finally. Okay, before I forget, we said our sender was going to be band creation method 1. So let me go and set that now so that I don't forget later and screw things up. All right, since TradeStation's being kind of slow tonight, we'll just make one more window. So we'll have them run band creation methods 1, 2, and 3. But you see the idea here, you can extend it for yourself. Do it at a time when TradeStation is being more responsive and they're not doing maintenance on the server farm. Okay, he's still not done yet. We can see that the other one is kicked off now too. Come on, Trade Station, what are you doing tonight? Hmm. When you see stuff like this, it usually means he hasn't completed the window yet. Refreshing the window. So that's kind of strange, but like I said, we'll only do one more here because TradeStation's been really slow tonight. So since we copied this window, which is already a receiver, we only need to update the band creation method number he's going to be doing and the directory where he's putting things in. Everything else should already be set up. So this next window should go to receiver number 3. Let's see what's going on here. Okay, here we go. So we'll go in here and we'll change this guy now. He's already linked with the symbol link and the interval link, so that's good. You don't have to do that. We come in here, we can do band creation method number 3. And we should just have to change the directories for the log and summary. Oh, I made a mistake. That other guy should have been receiver 2, not 1. And this guy becomes 3. Over here. It's 3. That should have been it, because he's already set up to be a receiver. Yep. Okay. Come on, trade station. Oh, actually, I was right. This guy should have been receiver number 2, not 3. No, it doesn't matter. For our purposes here, they're just separate directories. So we'll be able to run our test. All right. Okay, so now if we got everything set up right, we should be able to come in here to the sender. Sender should be band creation method 1. Our window here should be band creation method number 2. Our third window should be band creation method number 3. So let's come in here to the sender. And we can come down here and turn on the logging. We need him to put his stuff in his own directory. He has the sender directory. The other guys were the receiver directory. So we have a sender directory here. So I'm going to insert sender in the right place here, right after test. Sender is underneath test. So that'll put the log in the right place. I'm going to enable the band test. And we'll put sender in here so it goes to the right place. We already told him to send his settings. All right, so let's see what happens. Yep, there it is, send settings. And now you should do all three windows. Now, when we were doing this on TradeStation 10, update 56, we were actually able to set up 24 windows in this way and actually get him to run, 24 tests in one shot, essentially. Depending on how many cores you had in your system, TradeStation could run up to 16 of those tests simultaneously. It would usually result in your CPU fan kicking up quite a bit, as it would really push your system pretty hard. And if you had more tests than you had cores, the remaining ones would just get scheduled, and when a core finished up a test, then it would start, the next one. So it was a convenient way to do mass testing. Update 60, they changed something, and we were kind of cut back to being able to only do about 8 windows linked this way reliably. They have since made other changes. We haven't had this particular update for very long, so I'm not sure exactly what the limits are on. I think this machine's probably update 72. They're starting to play with an update 73. Let's go see if we can tell what he's doing. He's not maxing out the system like he used to. Let's see down here. He's not showing it here. Interesting. But he is showing it up here. See, in older versions of TradeStation, you would get, let's see, this is orchart.exe. You get one of those launched per core that was being used. Now, like I said, they've made changes, so I'm not 100% sure what they're doing now. Let's see, is he actually done? Did he do them all? I don't know. Let's find out. So under sender, we have our 2 files. We have our band test summary. And we can see he did band creation method 1, which is what we told him to do. band creation method 1 draws the zones or the bands very narrow. And we can see the success rate was less than what we were getting from band creation method 3 or band creation method 5. And the points in play was less, but not by a whole lot. Well, compared to band creation method 3, it wasn't a whole lot, but compared to band creation method 5, it was a lot. Okay, if we go back up, I'll go on receiver 1. We have ours results here. This is band creation method number 2. You can see that right here. So we got that one set up right. We come down here to our summary. Oh, will you look at this? He's got the best success rate we've seen yet. And he's got the best points in play so far by a little bit ahead of band creation method number 5. Very interesting and a bit unexpected. Let's see, I think we mistakenly put those here. Well, maybe not. Oh, trade station, what did you do? Do we have a typo or something? Okay, this is band creation method number 3, that's right. Okay, while we're here, I can go and fix the directory anyway. This should be going to directory number 2. Okay, set to receive. So I'm not sure. Have to talk to TradeStation. See what they've changed. Sometimes when this happens, just restarting TradeStation sorts things out, but still, it's annoying when it does happen. Okay, we're actually over our time limit here. So this is going to conclude tonight's session. When this is done, we'll go look at that the last result. But we've looked at the band test and the information provided by the band test and how we can use the band test to actually measure the changes made or resulting from something we have changed in the system. And we saw an example here where we definitely had a change in the performance just by changing the band creation method. In the particular test period that we looked at so far, band creation method 2 was the winner. We still have, of course, have others to check, but from the ones we looked at, band creation method 2 was performing a little bit better than band creation method 5. But again, this is the kind of thing you need to look at over time. Okay, here we go. This is back to band creation method number 3. So this should reproduce our original numbers here. And it pretty much did. Yeah, there's the 19,847. And so you get an idea of how you can go and play with your settings and see the actual performance that results from the changes you're making to your settings, and how you can potentially go and optimize your settings to give you the best results for the markets that you're actually trading. Now, once you have your optimized settings determined, you can then potentially use other features of the tool, such as OSF files, to save those optimized settings and to get the tool to automatically use those optimized settings whenever you go to the market that you set those settings up for. So going through, doing the back testing, doing the optimization can improve your results. And with the OSF features of the tool, you can make it convenient to use those different settings. So anybody have any questions about what they've seen tonight? Now, we've seen also here a general way for trying to set up your system so that you can take advantage of some other features of the tools, to be able to run, multiple band tests, controlling it from just a single window, potentially. You can extend that farther. It's too bad we didn't have time to actually get into that tonight. But another way that you can set this up is with OSF files. And you can use the same basic ideas for what we're doing here, setting up different directories for each of the windows that's actually going to run a band test. And you can have those windows look to those separate directories also for their OSF files. And then instead of having manual overrides to determine what a specific window is going to test, you can do it through OSF files. And doing through OSF files can be much more convenient because you can then save the OSF files for a particular test setup. And when you want to run that test setup again, you just take out your archive of the OSF files, unzip it into the directories, and you're ready to rock and roll. And you can do it with the same workspace that you used, for everything else. So there's lots of different ways you can combine the features to achieve different results depending on what you're after. Okay, last call for questions, comments, observations.
I don't have any questions, but yeah, tonight you answered a lot of questions I had before this. The back testing part was kind of the biggest thing I was looking forward to. So yeah, thank you for kind of explaining a lot more with that. Yeah, I'll mess around with it this weekend, and but yeah, it all made a lot of sense. So thank you.
Okay, great. Thank you. And again, if you have any questions or comments or anything else, please feel free to contact me. We do have the session tomorrow. I'll give you a chance to ask questions at also. You know,
I actually work. I work Saturday, so I was. Yeah, I was actually just about to message in the chat that I had to go to bed. I got to be up in like 5 hours. But yeah. But
don't let
no,
me hold
no,
that.
yeah, I appreciate all of it. Yeah, thank you.
Okay, great. Thank you. Thank you for coming.
Yeah, yeah.